And by the way, I'm going to try to record what I'm doing in class so that you guys, and I'm posting it on Canvas so you guys have an extra resource in case you're ever like whoever sits here. Grant's not here today, so he could watch this. Okay. The objective for section 1-2 is students will be able to understand basic terms and postulates. So the first term is a point. Okay. A point is an undefined term. And the reason it's an undefined term is in order to define a point, you almost have to use the word point. And so if I say, what is a point? You just got to say, well, I kind of know what it is, but I can't really put my finger on it, right? You can't. So this is what we call an undefined term. And a point indicates a location and it has no size. So the way I like to tell students to think about a point is, imagine that you have a pencil. You guys know what a pencil is. Imagine have you ever got a pencil like super, super sharp? Mm-hmm. It's so sharp that as soon as it touches the paper, the end of it breaks, right? Because it's so sharp. Imagine that you could make this pencil as sharp as possible, and then you could just barely touch the paper. Now, when that pencil touches the paper, it makes a little point on there, right? Is that point the same size as an actual point? That little dot? The answer is no. Because guess how big a point is? It literally has no size. So you would not even be able to see it. If you zoomed in with an electron microscope, guess what you would still not be able to see? A point. It's that small. It's so small. It's smaller than a cell. It's smaller than mitochondria. It's smaller than an atom. So it's kind of weird. Anyways, we use a capital letter to denote a point. We use a dot to represent a point. This dot, though, isn't technically a point. Does that make sense? Another undefined term is the term line. Now, most of you guys are, I'm sure, familiar. When we draw lines, we usually draw something like this that's straight, and we put arrows on. So that's a line. This is also undefined because if I asked you to define a line, guess what word you typically want to use when you start talking about a line? All the points that are in a, and then you want to use the word straight, and then the next word you want to use is line. This is an undefined term as well, okay? A line is represented by a straight path that extends in opposite directions with no end and has no thickness. The reason it has no thickness is guess what it's made up of? It's made up of points. How big is a point? A point has no size. So this thing actually has no size either. Now, here's where we got to be careful. We need to make sure that we know how to use correct notation in this class. So when we want to write line, like this line right here, the easiest way to write line is just to refer to it with a script letter like L. That's Lionel. Lionel Richie. Thank you. Most of you guys probably, do you guys even know who Lionel Richie is? Okay, anyways, sorry. The other way you can name a line is you could use 2 points on that line. So here's a point A, here's a point B. So we could also call it line AB. And then you could even, if you wanted to, someone else could say, well, hey, Mr. Allen, can I call it line BA? Can you do that? Well, let me ask you this. Are those 2 points on that line? Mm-hmm. Then you can. Here are 3 different ways to refer to that line. They're all correct. The third undefined term is plane. And again, I know that you guys already know most of this stuff, but I want to go over it. So now what you got to do is, I like to think of like the floor is kind of like a plane. The difference though is the plane, guess how far out it goes? It goes out forever. And it goes out forever this way. So it's like infinitely long in all directions. But guess how thick it is? Well, it has no thickness because you can think of it as a bunch of lines, right? So we usually draw in kind of this shape here, like a parallelogram. And here we use a capital letter that's kind of scripted. So that's plane P. The other way you could refer to this plane is just give 3 points that are on that plane. They technically have to be non-collinear. Okay, so now let's talk about something that is defined. A segment does have a definition. This is our first defined term. And a segment is just part of a line. It's not the whole line. It's just this part here. It has an endpoint A. In this case, it has an endpoint B. And then it's all the points on the line that are between A and B. How we write that is we would call it segment AB. And then instead of putting arrows on the top, we just leave the arrows off. That's a segment. Could we call it segment BA? Sure can. Okay. And then here's another defined term. We have array. Array is similar to a segment, but instead of it stopping at both endpoints, it extends in one direction. So here's array. So this is, again, part of a line that consists of an endpoint. This is the endpoint. Is this point over here an endpoint? Does it end there? Nope. So it has an endpoint, and then it extends in the direction of B. The way we write this ray is this way. And by the way, that's the only way we write that ray. Can anyone tell me why this would be incorrect? I'm sorry. What's your name? Anthony. Why?
Because the line's not pointing that way. The line.
You mean the arrow?
Oh yeah, arrow. The arrow's pointing towards with the.
Yeah. Sure. Exactly. The ray's going in this direction, I think, is what he's trying to say. Another way to think about it is this: what's this guy over here? That's the end point. Or you could call it the starting point if you want to think of it that way. This is the end point. This is where the ray starts, and then this tells you it's going in the direction of B. Does that make sense? So if this was a quiz question and you put this right here, unfortunately, I'm going to have to mark that one wrong. Okay? Opposite rays, I think that's pretty intuitive. Okay, so let's talk about some postulates. Do you guys know what postulate? Who can tell me what a postulate means? What's a postulate? Anybody know what a postulate is? Okay, a postulate is something that is assumed true. In other words, if I tell you it's a postulate, even if you don't like it, you just got to go with it. Now, later on, we'll talk about theorems, like you guys heard of the Pythagorean theorem. Theorems are things that can be proven. You cannot prove this statement, but we're going to just go ahead and assume it's true. And so here's what this this postulate says. If you have 2 points like A and B, then guess what they form? One line. Okay. In other words, what I'm saying is this is the important word here. One line. Through 2 points, there's exactly one line. In other words, that line is unique. Now, can we name that line in different ways? Yes. But there's only one line, AB in this case. Does that make sense? You can't have some other line that does something like this. You see that red thing? By the way, you guys all know that's not a line, right? This postulate is very important because it basically says you can't have this. You can't say that line M exists. There's some other line that goes through A. No. What's the only line that goes through points A and B? Line T. That's the only one. It's unique. It's the only one. Postulate 2, this one's pretty self-explanatory. I'm going to just say it, and I bet you'll know the answer. 2 lines intersect in, oh, maybe not. 2 lines intersect in, how many points? 1 point. If you have 2 lines, so here's line AE, you see line AE? And then let's say you have another line, BD, or DB, it doesn't matter. Guess how many places they can intersect? Only one place. In this case, they intersect where? At point C. That's the only place they can intersect. They cannot do this. This is not possible. And then let's call this over here point, I'll call it point F. Is this possible? Not possible. It is not possible for these two lines to intersect at two places. This postulate tells us that they only intersect at exactly one point. So they can't intersect anywhere else. So if we know they intersect here at C, then they don't intersect anywhere else like F. This postulate says basically the same thing, but about planes. It says that if two planes intersect, guess what their intersection is? Okay, let's do this. Would you guys agree we could think of this front wall as a plane and the floor as a plane? Where these two guys meet, where do they meet? They meet down here, don't they? What would we call that place where they meet? We would call it a line, wouldn't we? Now, guys, I know that my plane up here on the wall isn't perfect, right? It isn't perfectly flat and all that. But hopefully you can kind of imagine that this wall comes down to the floor comes to the wall. They form a line. And guess what? Guess how many lines they intersect at? Again, one line, okay? So if I tell you the front wall and the floor meet at that line right there, they don't meet at any other line. That's the only line that they will meet at. And I think this is our last postulate. The last postulate basically tells you this. If you have three non-collinear points means they're not all on the same line. Guess what they have to be on? Exactly one plane. This is the one that's probably the hardest for students to remember. Most everyone knows that two lines intersect at a point, right? It's pretty intuitive to understand that a plane that hits another plane intersects at a line. This one says if these 3 points, would you guys agree those 3 points are not on a line? Then they will define this plane uniquely. It will be the only plane that those 3 points are on. There's no other planes that those 3 points are on. Okay, now I'm not going to go through these practice problems because I already did that on the video, okay? But before I do anything else, does anyone need anything explained about our definitions or our postulates? I think we had 4 definitions and 4 postulates. Actually, I think there was 5 definitions. Okay, you guys ready to do some practice now? So now I'm going to let you guys do some practice here in class. So I just went over what we just did on the video again, and now we're going to practice some more in class. And I'm going to pause my video now. Sorry. So when we talk about distance, why do we need these absolute value symbols when we do the formula, if you will? Why do we need the absolute value? Anybody in here run or anything like that? Ever go running? What's your name again? Sorry. Anthony. Anthony, when you went running, last time you went running, did you ever run like -2 miles?
No.
What if you went 2 miles, you just say I went 2. You don't say you went -2, right? In fact, what's the least amount you could go? 0, which means you didn't go anywhere, right? But as soon as you go somewhere, it is a positive number, right? Guess what the absolute value always does? It makes it a positive number if it's negative. So that's why that absolute value is there. Okay? Oh, I should mention one more thing. The length of segment ZB is written with ZB, and guess what we don't put on the top? The line segment symbol. So this ZB means the segment ZB. Guess what this means? The distance or the length of segment ZB. Okay? These are all little subtle things that you got to practice and learn how to do. Okay, I'm not going to, actually I do need to do. This is the most important slide on this presentation. Segment addition postulate. Can I explain it to you? It's super easy. Ready? You see this segment right here? It has 3 points, A, B, and C. Let's say I told you that this distance was 2 and this distance was 7. What's this whole distance then? 9. Isn't that intuitive? All it's saying is this. If you have 3 points on a line, and one of the points is somewhere in the middle, this distance plus this distance is whole distance. That's all it's saying. In other words, it's saying the length of AB, that's from here to here, the length of AB, plus BC, that's this length, here to here, is equal to what? B or AC. He said it right. I almost said it wrong. Good job. That's right. Okay? Most important slide. By the way, you guys know I post these notes on the Canvas page if you want them. Okay? All right, so let's do this. Let's do one example with segment addition partial. And then we need to talk a little bit about one other thing, and then we'll be done. You guys see that segment over there? It's got 3 points on it, right?
Yes.
If I want to figure out, first of all, let's talk about this. How do I find x, right? Well, the first thing I know is this. What is EF plus FG? What is the distance from here to here plus the distance from there to there? What's that got to equal? EG. You with me? So EG. This plus this is the whole thing. This plus this is the whole thing. That's the first thing you want to write down on your paper. Oh, by the way, what is EF? Well, it's 8x minus 14. What's FG? 4x plus 1. Harder question. What's EG? Oh, they tell us what it is. Right there, they told us what EG was. It's 59. So I don't have to figure that out. They tell us it. That's 59. Well, they have to give you more information. If they didn't tell you that, unless they tell you that's a midpoint or something. By the way, is this the midpoint? Don't know. It kind of looks like it might be, but it kind of looks like EF's a little bit longer, doesn't it? Now, how in the heck do you solve that? Well, now we're doing Algebra 1 stuff, which you guys all took already, right? So you guys remember that. What's 8x plus 4x? That's 12x. What's negative 14 plus 1? Negative 13. Now what do I do? Add 13 to both sides. I'm going to plus 13 plus 13. So that gives me 12x equals, and I think that's going to be 72. And now what? Divide by 12. So x is 6. Now, if x is 6, how do I find the length of this guy? Just plug it in. So EF has to equal 8 times 6 minus 14. So that's 48 minus 14. I think that's 34. How do I find this length? Plug it in. So FG is equal to 4x plus 1. So I got to do 4 times 6 plus 1. That's 24. Yes.
Instead of doing like the second FG line, could you just do 59 minus 34?
Absolutely. Ron has asked a great question. He's like, hey, Mr. Allen, I know this is 34. Could I have just done 59 and minus 34? Well, let's see what that is. What's 59 minus 34? Let's see here. That'd be 2. I think that'd be 25. Was he right? Yes. That's a good way to do it. Guys, you need to keep in mind in this class, there's more than one way to do stuff a lot of times. And that's okay. That's good. All right, last thing I need to talk about is this, and then we're going to do a little bit more practice, and then we'll call it a day. Segments are called congruent if they have the same length. So would you guys agree that the length of this segment AB is 10 because it says 10? And guess what the length of CD is? It's 10. So we call those segments congruent. And by the way, here's how we would write that. Have you guys ever seen that symbol before? It's an equal sign with the tilde on the top. That means congruent. It also means this is true. Here I'm saying the segments are congruent. Here I'm saying that their measures are equal. These two things, that's what this is saying. It's saying if their measures are equal, guess what? We call it congruent. So this is an important word that we're going to use a lot in class. Okay, I'm going to stop there with that. And I want you guys to, oops, let me go ahead and stop this again.